So yeah, I'm working in the briefing centre here in the plant in Cork, and my topic is to talk about a very exciting technology that EMC brought to the market not that long ago. So I'll give you a little bit of a context of the background of that. And of course, it's in the area of all-flash technologies. And as we've seen, the transition to flash is really, really exciting. It allows customers to work in a very, very different way. And EMC has been looking at this very carefully for a number of years, has been involved in deploying flash in the form of originally hybrid technologies with tiering and all of that. And that continues to be a good strategy for some use cases. But also having an eye on this idea of all flash arrays, was actually investing in some of the other companies against which we're now competing, but in the end decided to buy this company because they felt that this was very, very different, really unique technology and would allow customers to really transform how they carry out their IT operations. And I've been in EMC myself for a very long time, back since we had essentially one product offering, believe it or not, back since 1994. And in a way, if I was to go back in time a little bit, not back 21 years, but even to go back 5 years, and somebody used to hand me a crystal ball and say, well, if you could tell the future, what would the ideal platform look like? And in many ways, I would have described XtremIO, because I'd say, well, it would be very fast all the time. It would be very, very easy to manage, and it would also be very, very inexpensive. Well, for the right workloads, it would save customers a ton of money. And I think if you'd said that, people would probably say, well, you're obviously making this up. It doesn't really make any sense in reality. But for the right use cases, this is what people are finding with this technology today. So, and of course, the background, just to give a little bit of background of XtremIO, as you know, and you probably heard the bigger story about this yesterday, EMC has a long history of acquiring many, many companies. Some of those companies are very well known in the IT marketplace, and some of them just sort of slip in very quietly. Not many people have heard of them. Some of them make a lot of money for the company, over $1 billion, and carry on from there. And XtremIO is very interesting in that way, because I suppose a lot of the successful acquisitions, you're going to see a few things happening there. Like any company acquiring another company, you want to get a good technology, of course, you get good engineering talent, some great ideas, and also ideally instantly get lots of market share, get a lot of happy customers straight away. So XtremIO had some of that, but it was quite different in many ways. So it was acquired back in May of 2012. And the kind of unusual thing about it was there was no generally available product, no production customers, and EMC didn't release the technology for a further 18 months after acquiring the company. And despite that, this has been the fastest growing technology in the history of EMC. And we're fairly certain that means in the history of the storage marketplace, full stop, maybe even IT infrastructure, full stop. So this chart here kind of puts that into perspective, where first of all, into EMC context, insofar as we see some other very successful, very high-profile, well-known acquisitions that EMC has made in other areas of our business, and other examples of acquisitions that managed to exceed $1 billion of revenue, which is great. And even if you look at VMware, the growth of XtremIO has just been breaking all records. It's just like stratospheric growth in terms of the run rate being at $1.2 billion. So this technology almost kind of sells itself. Well, not quite that good, but you have to still sell it. So that's the EMC context. And of course, the broader context is there has to be a reason why people like it so much. And so it's an all-flash array, but I suppose it's what we would call more specifically a purpose-built all-flash array. And I think those two words are very, very important, because again, EMC looked at this and said, well, this is something which was designed from the ground up, where the people said we need to start with a clean sheet of paper, get rid of the older legacy ideas associated with spinning sequential media, because some of those things can be very negative, and we'll talk about that later on, and start off to say, well, what would be the best way of designing an all-flash array with all of the functionality in terms of how data is stored, in terms of how data is replicated, how data is protected, because flash technology is not just faster disk. It's not this full stop, and it behaves in a very, very different way. And that behavior can be very positive, or it can be a very negative experience, depending on the architecture. So not only have we broken the EMC records, but we've also broken the overall market share records. IDC projections, Gartner, top of the Gartner Magic Quadrant already, just shot up there very quickly. And this chart, this IDC information, is already fairly old. Just to point that fact out, you can see that there. So these guys don't come out with these numbers every quarter or whatever like that. I expect there'll be probably newer, fresher information coming out. But even at the beginning of last year, it was up at the top in the leading place. And EMC, of course, is already tracking this anyway in the background. And I've heard recently we're probably in excess of 50% market share. That's what we expect to see coming out as the official figures. XtremIO kind of started off in a way as a kind of a really magical type solution for VDI, because VDI is a very difficult kind of workload to handle. It's very choppy, and you've all this thing of boot storms and how do you manage cloning and all of the. So a great idea on paper, but to actually do that in reality, the kind of things that you need to do in order to get the right kind of performance and striping across disk drives and short stroking, it really kind of makes it almost not worthwhile doing it in the first place. So we've seen a lot of people backing off those kind of projects. So because this technology is so different, this was initially like a real dream solution to make that happen in a very efficient and very consistently high performance way. But what we see on here now, on 40% Fortune 100, so actually VDI is still a great use case, but it's actually been overtaken by database type use cases as the number one way that reason for people deploying XtremIO today. And I'll show you a summary of some of the kind of key use cases a little bit later on in the presentation. But just starting off, so a lot of people have talked about this concept of kind of sudden impact, where people have put this in, and there's just been an instantaneous, really incredible, noticeable difference. This is not just something that's incremental, it's a little bit better than what they had before, but it means they can run their businesses in a completely different way and has a really profound impact instantaneously on what they do in their practices. And this is just a couple of examples from different customers there. And these are public reference customers, so there's information out there. There's some interviews out there online and that kind of thing. And personally, I've seen a lot of healthcare customers coming through the briefing center from right across EMEA. There's an example of a healthcare trust where these guys were running an application. They had to come up with a lot of reports by 6:30 a.m. every morning. And they were finding themselves under an awful lot of pressure where they were literally right down to the wire. They were finished sometimes at 6:24, 6:20, 6:25. It was really right down to the wire, under serious stress, having to try and rewrite some aspects of their application to try and get right down there. They heard about XtremIO, looked at that, deployed XtremIO, and you can see, bang, the sudden impact. This literally allowed them to pull the finishing time right back from around 6:30 to 1:30 a.m. All of a sudden, they could breathe a sigh of relief. It had a profound sudden impact, and they could step back and really start working in a completely different way. Another public reference customer, this is a SQL Server, another great example of a use case for XtremIO. And what you see on the left-hand side is obviously the before scenario. This is a customer called Online Connect Educate. And basically, these on the black line, you're seeing the latency that they're experiencing. Pretty shocking stuff, right? It was spiking up to as much as 90 milliseconds, imagine that. And they could never get more than, on the bar charts, they could never get more than 250,000, no matter what they did. They couldn't get more than 250,000 IOPS. And then, bang, they put in XtremIO, and their latency came right down to less than 1 millisecond. all day long, consistently. And you're probably typically talking about circa 500 microseconds. And that's consistently the whole time. That's what people see. That consistency is very, very important. So basically, there's just a couple of examples, and we've many, many more examples in many different verticals out there. So really the three kind of key things that we see there is that this is allowing customers to have a profound impact on their business, doing things much faster, shrinking the time required to carry out different tasks, and doing things in a more real-time kind of a way. Actually, that first customer example I showed you, we can give you a link there. There's an interesting, about 20-minute interview between, let's say, the IT director from that healthcare trust and a guy called David Floyer, who's a key kind of consultant from an outfit called Wikibon. Some of you are probably familiar with that Wikibon site. And he was talking all about the benefits of XtremIO and his business and how it changed and how he does things. And I remember he was talking about one thing which kind of reminded me a lot of when people were starting to deploy virtualization technologies a few years ago, and were finding all the benefits, and we're coming up with this concept of a virtual first policy, where people started to bring out this rule where people would have to justify why they wouldn't put an application in a virtualized environment. And that reminded me of what this guy was talking about here. Because he was going on about, that's one of the things I remember from his interview, when they saw how different XtremIO was, they decided to implement a rule where people would have to justify why they wouldn't put their application on an XtremIO system. So I thought that was quite an interesting point. So that's the business. And then on the IT guys, it has a profound impact here as well. Because basically, this system is practically a self-managing system. And that's by virtue of how it stores data completely differently. Everything is done differently. So basically, this system is taking in data, is chopping everything up into standard packages. And then it's fingerprinting the data. And then, in a way, the way I think about this is that it's kind of constantly asking itself the question, do I have this data already? Do I have this data already? Do I have this data already? Based on looking at the fingerprint. In other words, have I got that fingerprint already? Now, if the answer is no, I don't have it, it has new unique data, so it writes it to the flash system. And the way it does that is it can do it with the speed of the flash. It balances this data automatically. This is intrinsic to how it works. So you don't need to go back and tune this. It's consistently less than 1 millisecond latency. Now, if the answer to the question is, oh yes, I do have that data, I've seen that fingerprint already, then imagine if it stored that data again. Well, if it stored the data again to deal with it afterwards, first of all, that would be expensive because it would take up capacity in flash to do that. It would be bad for endurance. It would wear out the flash prematurely, and flash is a consumable product. And it would also create back-end activity, completely unnecessary back-end activity in the array, which would use up performance cycles. So when the answer is, well, yes, I do have that data already, then it just doesn't write that data to the back end. And this is happening at incredible speeds, much faster than flash. It's all happening in memory. So it doesn't write the data again, it creates a tiny pointer. So this is using content addressing, using it in a very, very different way than a standard storage array. So it's a self-balancing system, self-tuning type of system, and you get that consistent performance even if it's almost full. And with that kind of constant asking that question, do I have the data already? If the answer is yes, it's not going to write it again. It's deduping it. It's intrinsically thin provisioning it. And it's also compressing the data. So for the right kind of workloads for which you get a good data reduction potential, you're going to get incredible total cost of ownership here. The ability to reduce your footprint, reduce all the operational costs. And what we're seeing is actually some surprising things there as well. So it's sort of thinking outside the box, excuse the pun there, but people have seen incredible savings in their database license costs, because now you can actually run your database much more efficiently right across the whole IT stack, the network, the storage. And this means you got less CPU wait time. You don't need to do compression anymore with expensive compression licenses in your database. because that all happens here at the storage layer. So we've seen some people saying, making that saving and then saying, well, if I can allocate that saving towards the capital cost of XtremIO, then it's a fantastic story. And basically, of course, if you look at this, the last time we saw a new iteration of mechanical disk was back when Bill Clinton was the president of the US, up to hijinks in his office, right? The last time a 15K drive came out. So yes, they got bigger, they got more capacity. They keep saying we're running out of capacity. They find some new way of standing up bits or whatever they're going to do. But it hasn't got any faster. And this gap in latency keeps getting bigger and bigger and bigger. But of course, a few years ago, there was the issue of cost and reliability, and those issues are all solved today. So this is really where all the investment has been going. The timing is fantastic, and we'll talk more about that in a second. So the timing, if you look back in 2012, Gartner looked at this very closely, projecting into the future. So there a lot of noise that's been created back then. And they wrote a paper about this, talking about the so-called gold rush in the area of all flash arrays. So things were really heating up there. So we started hearing all of these new names coming out, new startups that we hadn't heard of before. There was also, legacy vendors kind of trying to convert what they already had into something that it wasn't really in actual fact. And we'll talk about that in a second. But Gartner also talked about the fact that around 2015, their forecast was that 4 out of 5 of those vendors would disappear. They either wouldn't have enough investment, wouldn't have enough R&D money, or would get taken over by somebody else. We've seen that examples. The noise is starting to die down. Some of these companies are getting acquired for really tiny sums of money. So you have to be very, very careful there as well. And of course, if you look at that, at the end of the day, flash is not the same as disk. That's the reality of the fact here, because disk is spinning sequential media. And these are a couple of points in here, for example, like just taking one or two examples. What we see happening in a disk type array, legacy arrays, you've got log structuring. Log information gets packaged up so that it can get written efficiently onto sequential spinning media. Now, if you do that in flash, I often think flash is a bit like that game Tetris, where blocks are falling on the phone or something. You have to free up space to make space available for that new information. You can't just overwrite it as you would on disk. So you get this really horrendous situation of garbage collection to try and juggle around free space. And other things like post-process dedupe, RAID, which is by definition redundant array of independent disk. There is no disk in this, so that ends up being very inefficient. And you've got something called write amplification, which wears out this consumable technology too quickly. So there are just a few examples there of kind of disk-type paradigms which many people have made the mistake and the shortcut of putting that in their flash arrays. And XtremIO doesn't do any of those things. Again, it's a purpose-built all-flash array. They've started from the ground up and designed and built this completely differently. And that's why EMC bought this company and not one of the other ones. Now, if you want to see more independent information, I would highly recommend you looking at Wikibon articles. There's a guy called David Floyer. Have any of you heard of Wikibon? Have you anybody here look at Wikibon? No? It's a very good site. There's a wiki for everything, right? WikiLeaks, wiki this, wiki that. But Wikibon is a great one in the storage industry. And these guys look at, EMC and Pure Storage. They look at all the vendors out there. They go to all the shows. They interview all the executives and all of that kind of thing and find out all the latest information. So there's a guy called David Floyer, and he's the executive, or one of the specialists in the area of flash. He wrote an article about, believe it or not, how would you go to an all-silicon data center? And people are actually looking at that, believe it or not, right now. Not saying everybody's doing it, and it's a bit like people transitioning to all disk-based backup a few years ago. And he talked about the evolution, where you start off having workloads pinned to flash, and then we had a bunch of flash-optimized hybrid vendors. EMC was playing in many of these areas of the evolution as well and driving this. And then you've also got some vendors like Violin and Pure and that kind of thing. And some of these technologies are not really bad technologies, but they tend to be a bit more narrowly focused on particular workload types. and often generally active, passive, dual controller architectures. You have to be very, very careful with that when it starts to scale. And what he was saying is that the only way you can really realistically achieve that goal was by having, a scale-out all-flash array. And XtremIO, according to him, is the only one which fits into that category today, where you have global data reduction, global deduplication, and all of these things to get those efficiencies that you need, and that linear scaling of performance and capacity. And he also mentioned this 2015, 2016 has been a key time when you have that crossing point of the TCO of flash and disk. So we can send you links to that article. So really, the uniqueness, again, is not really so much in the hardware. It's more about the operating system, the XtremIO operating system. And again, it's a self-managing system, so the simplicity is incredible with this system. The scalability, you're scaling both capacity and performance in a completely predictable and linear fashion. All the services are inline, they're unstoppable. It's more like an appliance-type model. You cannot turn them off. We'll talk a little bit more about that. Apologies for that. It's completely balanced, like I said, self-balancing, consistently high performance, and I'll show you some comparisons in a minute, and very, very efficient technology. So the system itself, just talk a little bit about what that looks like. So basically, it's scale-out, fully active system. This is a kind of an inside view of what you have there. A lot of compute power in every X brick, which is the building block we have, a lot of RAM, and that's really where a lot of the action happens in memory processes. And you can have various X bricks, which will either have 13 drives, 5.2 starter brick, 5.2 terabytes, 10 terabyte, 20 terabyte, and now even a 40 terabyte X brick. And that's just the physical capacity. The logical capacity is typically way more than the physical capacity when you have data reduction, data deduplication. So what you typically get there, when you have the right kind of workloads, such as VDI, database, when you start copying your database, you end up having incredibly efficient, very high performance at a fraction of the space, power, and the overall operational cost than you would need to get the equivalent performance with legacy arrays. And I'll show you some kind of competitive comparisons at the end of the presentation to give you actual real numbers around that. So that's a kind of a family photograph of what's there today. So you can start with a single X brick, and some people, maybe in smaller environments, maybe a small VDI environment, found it a bit too big of a step in price. So EMC brought out this so-called starter brick, which is half populated, 5.2 terabytes. For example, you can have maybe 400 or 500 VDIs and get started there. You can have a 10 terabyte, and you can scale this out right up to what we call a beast, which is the 8 X brick system there, literally millions, 1.2 million IOPS at consistently less than 1 millisecond. And that's the beast, the newly announced system back in the EMC world. So depending on the kind of workload profile, you're still looking at incredible IOPS at consistently low latency. Again, from a management perspective, if anybody likes to fiddle around with technology and get all, fiddle with scripts and all of this complex setups, they're going to be disappointed because you don't really have much of that going on here. As I said before, it's a self-managing system. So it might be a little bit boring for these people. We often call them ponytails in this part of the world, right? So, it's very, very simple. There's really 3 basic steps: your initiators, your targets, and then you bind them together. I've seen a demo recently. Imagine how long it took to provision a new volume. 15 seconds. 15 seconds, crazy. I'm not saying that that's all that's required to configure the system in total, but that's generally day-to-day sort of stuff. So inline services, basically the data service that you have here, there isn't this concept of having to buy different software and configure and tune it. This is more of an appliance model. You get, it's constantly thin provisioning data, deduping it, compressing it. These are unstoppable data services. You get them when you buy the system. You cannot turn them off. As a matter of fact, in the EMC, before the last one, the EMC had a kind of a bit of a stunt, a Las Vegas-style stunt, where they said they would give anybody $1 million if they could prove that we would ever have to turn any of these services offline because we're under pressure. And I believe that's never happened yet. I'm sure there was quite robust terms and conditions, right? Writable snapshots is one of the really cool pieces of functionality, and this, in my opinion, is one of the reasons why database type workloads are now the #1 use case for XtremIO. So we have a great example here of one of our top reference customers. These are guys who've been dealing with XtremIO even before EMC acquired the company, so they're a very early kind of beta type customer. They're up in Scotland. They're called Bailey and Gifford. I don't know an awful lot about them, but I know enough to realize that I'm not a client of theirs, because they have all of these high net worth individuals where they're looking at all this ticker data from all around the world. They're investing these guys' portfolio, or their investment portfolio, and constantly reviewing where is the best place to invest their funds. And each day they come up with this report called the Crunch, and it takes a lot of analytics and crunching of numbers, basically. And they were finding that this was getting more and more difficult to go through that and get a competitive edge. They were using legacy hybrid arrays. They had a bunch of arrays, and they were taking a bunch of copies for DevOps, for reporting, for analytics. And actually, they were kind of restricted in the number of copies that they could take. They couldn't take as many copies as they wanted to because of time and costs and all of that. So then they came in, they heard about XtremIO, got very interested in that, put in XtremIO. And one of the things that really excited them was they have a big Oracle, DevOps environment there. And so this allowed them to put in a couple of XtremIO arrays. And in actual fact, they've, as far as I know, all of the production is based on XtremIO today. They have 2 systems there. And now what they have is, from the production, they can just take, to quote this guy, Sandy Bryce, the IT director, I can take as many free copies as I want to, all with the same performance, practically instantaneously, end quote. Actually, I had a briefing with a French insurance customer a while ago, and they talked directly to this guy to sort of share a story. So this guy loves talking about his positive experiences there. And this slide is a little bit out of date because it says 38 copies. The last I've heard is they're taking in excess of 50 copies. Now, I think the important thing on here is that the reason why we have dotted lines around those copies is because actually, and the reason why that guy said free copies, is that these, don't forget, are all in-memory pointers. So again, back to the question that it's asking itself, do I have this data already? And if that's a copy of Oracle or a copy of SQL, well, the answer is yes, I do. So I'm just going to create a bunch of pointers to that unique data in the back end instead of having to copy all these blocks to disk. So that's why they're instantaneous, they're all at the same performance, and it really redefines the way they run their business in every single way. So you see, starting at the bottom, from a total cost of ownership perspective, big savings in the normal, usual storage, power and cooling and all of that. But also these guys, imagine they saved £1.1 million sterling on their Oracle licenses, and saving on compression costs that they would have had to pay before. I don't know what these XtremIO systems cost, but I would imagine that £1.1 million that they saved in Oracle license cost was a really significant contribution towards the capital costs of buying the XtremIO system. So these guys absolutely love this stuff. And in terms of the way they run their business now, they can cut their batch in half. Their query times are almost cut in half as well. They're seeing massive data reduction, in this case from 36 terabytes down to 1.5 terabytes. Now that's going to vary with every customer, but that's by virtue of the fact that these guys are taking 50 copies of their data because of the kind of business that they're actually doing. This is actually what this slide is showing you, and something to be very careful about, because there was another great article written by IDC, and they talked about how to test an all-flash array compared to a disk array, a legacy disk array or hybrid array. And they were emphasizing how this is completely different because the technology is different. You have to watch out for different things. So they were recommending 5 full working days if you want to do a full test there. One of the things I remember from that is they talked about the FOB performance, which is shorthand for fresh out-of-the-box performance. And what you find is every array, EMC, Pure Storage, Violin, IBM, it doesn't matter, they all have fantastic fresh out-of-the-box performance. But they also talked about the absolute importance of the need to precondition the arrays, to go right through, touch every block, and then fill it up and go back to the beginning and start all over again. And that's what when you're going to see with the wrong architecture, the top line here against one of our major competitors. The orange color might give you a clue who I'm talking about. I'm not going to say any more than that, right? But what you don't want to see is a big standard, a big difference in the standard deviation between your best and lowest latency. In other words, what they call the right cliff, where you're going from a great fresh out-of-the-box performance to really big swings in latency. And that's what you can often see with the wrong architecture, where they have to catch up in the background. So I'm going to go through these next couple of slides very quickly, but there's also very good information on the total cost of ownership, very deep, let's say, white paper has been written by the Enterprise Storage Group, breaking this right down into business benefits, very detailed information here, operational benefits there, and that's the kind of summary of those things combined. But we can give you links to all of that information. People often like to see this because it gives you a very interesting view on how you would sort of achieve a certain result using XtremIO compared to legacy vendors, legacy kind of hybrid type storage infrastructures out there from our more traditional type competitors. So this slide is a kind of a no-brainer. People are often very convinced by this, and the numbers here are really, really compelling. So this is like sudden impact on TCO, if you like. Never mind all the experience. I'll wrap up now, but looking at the various different use cases, then this is increasing the whole time. So this is not just for one type of use case like VDI. We see people deploying this for many different things. Obviously, certain use cases are more suitable than others in terms of their performance profile, their potential for data reduction and all of that. But you can see on there some very, very good use cases. And then on the bottom, of course, looking into the future, some areas where we expect this to gain more momentum and newer selling opportunities that you might have there as well. Now, just to finish up on a couple of things, because sometimes people are a bit concerned about flash, and they say, well, yeah, it's very fast and blah, 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 but what about the reliability? I heard it can wear out and all of this. So we've been amazed and hugely positively surprised by this, because EMC, our QA people and the people in the factories and tech support and all that, they're constantly, with Six Sigma and all of these things, are looking at these different arrays, comparing the reliability of them and improving this, constant improvement the whole time. And they've been amazed by the reliability of these systems. So this is showing us the average number of callbacks of our, and showing the example of XtremIO, where in the beginning, it was even quite good back then. The average number of calls back to customer support was around 2. And by the way, these could be some stupid calls like, how do I log into the GUI? Right? And bearing in mind that this is pretty much a self-managing system, it's not a complex system that's going to evoke a lot of these calls with different things. So it's a self-managing system. This today is down to less than a half a call on average. So it just runs, it just works all the time. And in case anybody is worried about EMC standing over that, we have a program which is called the Expect More program. Customers love this. You can find more about this on emc.com. /expect more. I had a French customer a while ago, and they're asking about, what about this asset appreciation life cycle of 3 years or maybe sometimes 5 years? I'm getting sick of that. I want it to be a bit longer. And they were very happy with this idea because, now if people sign up for the 3-year maintenance, they can lock in the price, extend that for 7 years, get the same price locked in there because we're so convinced of the reliability of this system. But what happens if they have some unusual workload that wears out a SSD drive? And by the way, that doesn't matter too much. You can even have 6 drives failing one after the other, or even 2 at the same time if you're extremely unlucky, right? And the system will continue to run. But EMC will replace any of those drives within a 7-year period. So this system is as solid as a rock. Fantastic reliability, the best reliability numbers we've seen with any block storage array that we've had in the history of the company. So I would encourage them to go off, have a look at the site. There's tons of fantastic material on there, videos, usual white papers. Again, look at the Wikibon article. David Sawyer, he's got some great stuff out there. He writes about all different companies, so it's not just some pro EMC stuff. There's great interviews and talks about this evolution of flash into the data center there as well. And in terms of, I talked about the innovations there, just a quick summary on that, about the Beast, where we have the newer X bricks, the 40 terabyte X bricks. They can be scaled to 8 X bricks, which is huge capacity. Don't forget, if you're getting big data reduction, it could be 6 to 1, or it could be 100 to 1. Depends on the profile. You have to have a look at that, and we have tools to measure that. We also have replication. We have disaster recovery now built in. So Recover Point, which is a cool technology for disaster recovery, is built into the XtremIO system as well. It works with vPlex. So some nice new innovations. And I guess you guys can follow up back in India with a more detailed technical workshops and all of that. I think I'm kind of out of time at this stage. Does anybody have any questions, or do you want to move on straight on to the next session at this stage? Okay, no? Listen, guys, thank you very much for your time. Enjoy the rest of your time in Ireland, and hopefully we'll see you here again. Thanks, guys.
Thank you. What's his role?